Today we're going to talk about section 2.7, combining functions. So some of the ways that we can combine functions is to consider the sum. So sum means what? The answer to an addition problem. The difference. Which means subtraction. Product. Multiplication. And quotient. So sum we said was add, answer to addition problem, difference is subtraction, product is multiplication, and quotient is division. So we're also going to take into consideration the domain of these particular things, but the one specifically we're going to talk about is the quotient. If I have two functions, f of x divided by g of x, that are combining f and g through the quotient, we know this is a fraction then, right? So what do we know about every fraction? The denominator, g of x in this case, cannot equal 0. So because we learned that previously, denominator cannot equal to 0, that's going to help us define the domain. So that would be helping us define the domain. And we're going to do that with an example here in just a minute. So the first example we're going to look at is f of x equals 2x plus 5, and g of x equals 5x plus 6. Now, this next question is just a prior knowledge kind of question. What do we know about f of x and g of x? What kind of picture are we going to get with 2x plus 5 and 5x plus 6? We know each of those are linear equations then, right? Y equals 2x plus 5 would be the same as y equals mx plus b. So to graph this, we know that the slope is going to be 2 and the y-intercept is going to be 5. So which way is this one going to slant? It's going to slant upward because it has a positive slope. So we would go up 5 and put a dot, and from there we would do rise over run, rise 2 and run 1. Same kind of thing with this one because you got the x to the first again. This is linear. So this one's going to graph as up 5, and then from there your rise over run would be 5 over 1, rise 5 and run 1. So again, it would also slant upward because it's a positive 5. Anyway, that's just prior knowledge, kind of getting ourselves remembering. So A says to find f of f plus g, f minus g, f times g, and f divide g. And then it says, and their domains. Okay, give everybody a chance to catch up to that point first. So the first one we're going to look at is f of x plus g of x. Now you've done this before. We're going to take f of x, 2x plus 5, and we're going to add 5x plus 6. Combining like terms then gives us what? 7x plus 11. So there would be my sum. Now, looking at its domain, is there any restrictions? Is there a radical? Is there a fraction? No, so we know that our domain is going to be negative infinity to positive infinity, so all real numbers. All right, second one it says asked to find is f of x minus g of x. So we've got f of x minus g of x this time. So we've got 2x plus 5, that's f of x, minus, now, notice here we're putting in parentheses this time. So 5x plus 6 is going to go inside of parentheses. So why do we do that? Well, we're subtracting the whole g of x, not just the 5x. So this negative sign is going to distribute into every term that's inside that parentheses. So I'm going to have 2x plus 5 minus 5x minus 6, because you got negative times positive, negative times positive. Now when you put like terms together, 2x minus 5x gives us a what? Negative 3x, and 5 minus 6 gives me a negative 1. Again, our domain, each of these things is linear, so we don't have any fractions, don't have any radicals, so the domain is going to be negative infinity to infinity. So the next one it asks us to find is f times g of x. So what are we going to do on this one? Well, again, f is 2x plus 5, and g is 5x plus 6. So now we've got two binomials multiplied by each other. So what do? We do FOIL. 2x times 5x gives me 10x squared. Outside ones would be 2x times 6 plus 12x. Inside ones, 5 times 5x would give me 25x. And 5 times 6 gives me 30. So are we finished? No, we have to put common terms together. So I'm going to get 10x squared. So now I've got 12 and 25, both are positive, so we add and keep the sign. It's going to give me plus 37x plus 30. So our domain again on this one, no fractions, no radicals. So our domain is going to be negative infinity to infinity. Okay, give everybody a chance to catch up to that point. Then we'll look at quotient. Okay, the next one is the quotient. So we're looking at f of x divided by g of x. So our f of x again is 2x plus 5. And our g of x is 5x plus 6. So now we do have a restriction to consider. We've got a quotient, and the quotient has in the denominator 5x plus 6, but we know that the bottom of a fraction, the denominator, cannot be 0. So 5x plus 6 cannot be 0. The other thing is these won't factor any further than what they are, so they won't cancel out anything. So that is just what our quotient is. But now we have to consider this to find the domain. So we are solving for x, so I'm going to take a minus 6. 5x cannot be negative 6, divide 5. So x cannot be a negative 6 over 5. Now, we're going to put that on a number line first. So we're going to graph negative 6/5. Now, what do we know about negative 6/5? It can't be that thing. So do we use a filled-in dot or do we use an open circle? If it can't be, then we put an open circle saying that it cannot be that. But it can be everything else besides that. So how do we write that in interval notation? So our domain is going to be negative infinity to negative 6 over 5. So this part right here would negative infinity to negative 6 over 5. But since that's an open circle, we've got parentheses, union. Starting from here and going forward then gives me parentheses again, negative 6 over 5, comma, positive infinity. So everybody caught up to that point? So that would be our domain. The second thing it asks us to find is the B part. It says find f plus g of 4. Now there's two ways that you can do this problem, but the one that we've already done is we've already found what f plus g is. So we know that f plus g of x we found to be 7x plus 11. So what are we going to do? This is my function, this is my input, so we're inputting 4 into this function. So we're going to have 7 times 4 plus 11, inputting the 4 into it. So that ends up getting us 28 plus 11, which would give us 39. All right, so let's try f minus g of 4. So we go over to our work that we've done so far. We said that f of x minus g of x was going to be negative 3x minus 1. Okay, so that's what we already found. But now our input is what? 4 again. So I get negative 3 times 4 minus 1. So we have negative 12 minus 1 gives me what? Negative 13. Okay, give everybody a chance to catch up to that point. All right, the next one it asks us to find is f times g of x. Now, we already said f times g of x was, let's make sure we write it down correctly, was 10x squared plus 37x plus 30. So if we want f times g of 4, what are we going to do? We're going to plug in 4 for x. So 10 times 4 squared plus 37 times 4 plus 30. Now we have to be careful with, please excuse my dear Aunt Sally on this one. We have to make sure we do them in the right order. So the first thing we're going to do is do the exponent here. 4 squared, excuse me, 4 squared is 16 times 10 gives me 160, plus my 37 times 4, if I multiply that out, I get 148, and then plus 30, and then I just add straight across, and I get 338. All right, the last one it's going to ask us for is f divide g of 4. So we said f divide g of x is just placing one on top of the other. So we had 2x plus 5 over 5x plus 6. So we're inputting 4, so I get 2 times 4 plus 5, 5 times 4 plus 6. So what does that give me? 2 times 4 is 8, plus 5 gives me 13. 5 times 4 is 20, plus 6 is 26. Now, can we leave it like that? No, because 13 divides evenly into 26, so dividing 13 into there once, 13 into here twice. So I get my final answer to be 1/2. Okay, give everybody a chance to catch up to that point. Okay, the second part we're going to look at is what we call a composition function. Okay, so we're given two functions, f and g. The composition is going to look like this, f circle g. That f circle g is the way that we read this. Sometimes people call it fog. But f circle g tells us something. So f circle g of x is f of g of x. So basically what are you doing? This one you're inputting g into f. So input g into f. So if I have g circle f of x, then I've got g of f of x. So now what are we doing? We're inputting f into g. So get ready to catch up with that, and then we're going to try an example. Okay, so we're going to have f of x equals 2x plus 5, and g of x equals x squared plus 2. All right, now, again, before we go into composition, I want to just look at some prior knowledge again. This 2x plus 5 is what kind of function? A linear function. So in this case, it's x to the first, so we know it's going to go up 5 for the b, the y-intercept, and then rise 2 and run 1 for the slope. Y equals mx plus b. This one over here is a quadratic. We know it's a quadratic because it has a squared term. We also know that this is the basic parabola, but this plus 2 moves it up 2. So this one's going to be a parabola and this one's going to be a line. But that's, again, that's not exactly what we're looking for here. I just want to bring that in for prior knowledge. So we're going to find first f circle g of x. So that's going to be what? F of g of x. So we're going to do f circle g, that's f of g of x. So that means that this is g of x. I can place x squared plus 2 into that position. So f of x squared plus 2. Because all I did was substitute something that was equal into that position. So g of x is x squared plus 2. But now this says that that's the input into f. So this input here goes in for that x. So I'm going to have 2 times x squared plus 2 plus 5. So all I did was plug in the input for f into the function. So now I distribute 2x squared plus 4 plus 5. So my answer is 2x squared plus 9. Now that's for f circle g. So now if we wanted to go g circle f of x, and be careful, make sure your circle doesn't fill in, then what is this going to be? G of f of x. Now we still have our functions up here at the top. So now which one are we going to plug in? Well, this says f of x inside the parentheses, so we're going to place f of x in place of that f of x. So I've got g of 2x plus 5. So my g of 2x plus 5 then tells me what? That means that the 2x plus 5 has got to go into the input of g. So this 2x plus 5 is going to go into the x. So I have parentheses 2x plus 5 squared. Okay, 2x plus 5 goes in for x. So that should be a parentheses. Plus 2. Now to simplify this, squared means 2x plus 5 times 2x plus 5 plus 2. Now one of the reasons why I put it side by side is a lot of times if people don't put it side by side, they lose the middle term. So we've got 2x times 2x gives me 4x squared. Outside one's 2 times 5 is 10. Inside one's 5 times 2 is 10. So 10 plus 10 gives me plus 20x. And then the last one's times each other. 5 times 5 is 25. But then let's don't forget our plus 2 that's still up there. So now combining like terms, G circle F of x is going to equal 4x squared plus 20x plus 27. Now, if we look at this G circle F of x and we look up here at F circle G of x, we can see that those are not going to be the same. They're going to be different. So they're not commutative. Commutative means that we can switch the order and be the same, but in composition it's not the same. Okay, so give everybody a chance to catch up to that point. Okay, so far they've given us the functions and we found the compositions. So the next one's going to say, what if we get the composition and we have to find the functions that make it. So what if we get the composition, then we have to find the functions that made it. All right, so the example would be, I would give you f of x equals the 4th root of x plus 9. Okay, so this is the composition. This is the ending that we had from before. So what I'm looking for is plugging something into something else. So the first thing we're going to look at is taking this x plus 9 and making it into some function. So f of x equals x plus 9. So that would be one possibility of the thing that we're inputting into something else. Well, what would the function look like that we were putting it into? So the function we would look at putting it into would be g of x is the 4th root of x. So if I put x plus 9 into this, then this x right here is the same as that input there. I know this is kind of confusing, so that's a 4th root. So these would be my f and my g. But am I finding f circle g of x or am I finding g circle f of x? Okay, so which one are we plugging in? If I have g of f of x, that's g circle f. That would be putting x plus 9 into here. So g of x plus 9. And then that would putting x plus 9 into there, which would give me the 4th root of x plus 9, which is the original one that we wanted to find. So these would be my two functions that make up that composition of g circle f. Okay, the next one we're going to look at is an application problem. So I'm going to go ahead and switch this page out. So we're going to look at example 7, page 215. We're going to start with a picture. And then I'm going to read it to you out of the book. A ship is traveling at 20 miles per hour parallel to a straight shoreline. The ship is 5 miles from the shore. It passes a lighthouse at noon. The first one says, express the distance between the lighthouse and the ship as a function of d, the distance the ship has traveled since noon. So find a function such that s equals f of d. The second one says express d as a function of t or time. So find g so that distance equals g of t. And then what does the composition express? All right, so that's a little overwhelming, I know. So the first thing it says is the ship is traveling at 20 miles per hour parallel to a straight shoreline. Okay, so we're going to label some things. S is going to be the distance between the lighthouse and the ship. As a function of d. All right, now we say it's as a function of d, but what does d mean then, right? So we're going to explain what d is. So d is the distance the ship has traveled since noon. So we're going to give you a minute to get the picture drawn, but if we look at this right here, you're saying that the ship is 5 miles from shore, so there's my shore, and then this is the distance that it's going to travel past noon. So this ship is coming along here at 20 miles per hour, and then it passes the lighthouse at noon. So d is the distance it travels since noon. And s is between the lighthouse and the ship as a function of d. So the further out that d goes, the longer the s gets, right? So s depends upon d. Distance between the lighthouse and the ship as a function of d. So we're going to say s equals f of d. So we have to know what the distance is for d to be able to find the distance for s. Okay, now we're going to get another one because we talked about the idea of the noon situation. So we have another variable, d equals g of t. So this distance that's traveled here depends upon how much time, because we said that it crossed there at noon. So this would be how much time it is after noon. So this is going to be distance is the function of time. Now we know the formula for distance is distance equals rate times time. So our rate, they told us, was 20, let's see, was it miles per hour or meters per hour? Miles per hour. So we're going to place the d equals rate times time is going to be 20 times t. Now we also know something else about this picture. What kind of triangle do we have here? We have a right triangle because it passes and goes parallel to the shore. So we know that this right here is going to form ourselves a 90-degree angle. So we know we have Pythagorean theorem. So this is like our a squared, b squared, and c squared. C is our hypotenuse. So we have that other formula then. S squared equals 5 squared plus b squared. So this is a function, S is a function of d, the distance. So now what are we going to have to do? Well, we're going to go ahead and simplify this for S. So we're going to take the square root on both sides. Let's do that over here. So S equals plus and minus the square root of 25 plus d squared. But we have the distance, and we know distance is always positive because we said S was a distance between the lighthouse and the ship. So our S is equal to a positive square root of 25 plus d squared. But back here we said we wanted the distance to be a function of that. So we're placing in the d equals 20t, and we're plugging that into the other function for here. So my S now is going to become the square root of 25 plus 20t squared. So now it says that S is the expression which represents the distance of the ship away from the function as a function of time. So this would be my final answer. So this was a function, distance equals rate times time, and then this one was the function, and then we combined these two functions. So we have composition of functions. Again, you can look that one up also on page 215 in your textbooks. All right, the last thing we're going to look at is composition of a function using a graph. So give everybody a second to draw the picture. All right, so we're going to find f of g of 2. So this one is the function f, and this one is the function g. Okay, the top one is the g. See how where the g is here and the f is here. So composition, we said we had to find g of 2 first. So to find g of 2, what do? I go to the 2 on the x-axis, because that would be the input, the 2, and then I go up until I'm touching g. So when I go up until I'm touching g, you'll notice that I'm right across from the 5. So the g of 2 equals 5. So we're putting that 5 inside here for g of 2. So I get f of 5. But I'm not done yet because I need to know what f of 5 is. So I go over here to f of 5. 5 again is my x. So I go to 5 and I go up until I'm straight up here. So it stops at, looks like it stops at 4. So my f of 5 is going to be 4. So my answer for f of g of 2 equals 4. So let's just play with it for a second. If I wanted to find what g of 0 was, what would I do to find g of 0? Well, I would go to 0 and I would go up to g. So it touches at 3. If I wanted to know, let's see if we can figure out another one here that looks obvious. Okay, so if I wanted to find f of 2, I would go to 2, and now f is this one, so I would come down to this one, so it's across from -2. So you're just going up or down depending upon where your x is. And again, if you want to look at this one in the book, it's page 217, number 33. Section 2.7, combining functions. Thank you.